Oh, no, never mind.
Sorry. Okay. Right, cool. And then I'll share my screen. Wait a sec. Yep. You see that, right? Okay, so let's go through. The first one is a NumPy. So the aim, the goal, at the end of the session, you'll be able to understand the basics of NumPy and Pandas and Matplotlib. So let's run it. Since I already have it, we'll just say requirement already satisfied. The version doesn't really matter. So the first thing, when you create a NumPy array, you say np.array, and then you put a basic Python list in it. So if you do it, you will see a NumPy ND array, and the shape is 4, nothing. You will know what this means in the later of this notebook, but let me tell you right now. So the 4, nothing means that your NumPy array is just a list. Okay, so how do you initialize NumPy arrays and matrices? So let's go through the to-do thing. So when you create a matrix full of ones, it's just simple. You just say np.ones. This tuple here is a dimension. So you're making a 2 by 2 one matrix. So next thing, a matrix full of zeros. It's just a simple one, np.zeros. If you could go to the NumPy documentation by just Googling it, you can see that. So right now you're making a matrix that has dimension 2 by 3 full of just zeros. So 0, 0, and then the column, you have 3 zeros as well. So create an identity matrix. So identity matrix, if you say np.I, which is quite like a pun, if you say np.I, you're making an identity matrix that has 1 in the diagonal in the matrix. So create a matrix filled with random numbers between 0 and 1. When you're making random numbers, you have to do random.random. So in this np.random attribute, you have another attribute such as like random.randn, or random.just_rand. In this case, you can just use random.random. All the things have different meanings. You can look up in the later after this lecture. So you're making a 2 by 2 random matrix. So the elements of the matrix will just the random values. Okay. So now let's create an array which has 0 to 9 as its elements in sorted order. So this is the expected output. You want to create this one. So this time you say np.range 10. Matrix placeholder without initializing entries. So sometimes when you're doing machine learning, you just want the empty NumPy matrix in order to fill in the matrix. So in order to make just a placeholder with random variables in it, you can also use a random.random, like I said before, but NumPy has some kind of fancy way to do that. You can just say NumPy np.empty. So by doing this, let's see. np.ones, you're making this. np.0, you're making this. np.d, this is the diagonal matrix with ones in diagonal. Matrix E, random values in it, right? This is just a random value. Matrix F, by arrange 10, you're making 0 to 9. And then this one, last one, you're making also a random values in it. So to be honest, I don't see like that much of difference between empty and random.random. But yeah, NumPy has it. So why are you using NumPy? So in machine learning, there are tons of matrix calculation and vector calculations. So if you're using just a for loop to calculate like vector calculation, matrix calculation, you have to use like nested for loop, 4 inside of 4 inside of 4. That will cost a lot of computational cost. But if you vectorize it rather than just iteratively calculating it, your time will be very much shortened. So NumPy does that. So that's why we are using NumPy. Okay, so what does this do? np.arrange n, which means that you're creating 0 to 999, right? And then you're squaring every elements. And then you're doing it with the NumPy, but if you're doing it with the for loop, it will take loads of time. You see the time difference in microseconds, right? So this is why we're using NumPy. Let me show you more relevant one, because this one usually you don't do this in machine learning, I guess. So which is more relevant to machine learning is a matrix calculation. So let's say A is equal to random.random, and you want to create, I don't know, 1, 2, 3, 4, I guess. And let's create B, np.random.random. Yeah. And then let's actually time it. Oops. Let's import time. And then I'll say start is time.time. And then end is equal to time.time. This is just the way you time how much the code runs. So let's say C is equal to np.dot A and B, which is a matrix calculation by NumPy method. And then let's print C and print end minus start, which is the ellipse time. Okay, let's see. So this was the result, and it took this much of time, right? This is quite hard to look at. So let's multiply by 1,000, which means I'm converting nanoseconds to milliseconds. And then let's use for loop. I'm just going to copy this. And then maybe I have to make C to 0 again. So this time, rather than doing np.dot, I'm going to just use for loop. So for I in range this, I'm going to do C. I'm going to update the C by doing C equal to AI times BI, right? Okay, let's see. Great. So this was the NumPy way, and this one was the for loop way. It took 0.25 millisecond, but the for loop way took 8.6 milliseconds. Way much better. NumPy is way much better, right? So this is why we're using NumPy. So let's do the matrix calculation. So np.transpose, we're going to do np.transpose and then dot product, inverse the matrix and get the diagonal of the matrix and reshape it. Okay, so initialize the data we'll use below x. This is what, this is the one, and then let's transpose an array. So to transpose, what do we have to do? You can just do x.t, right? This just t, uppercase T, is just an attribute of a NumPy array, which just transpose, which just returns the transpose of the array. And then let's do, what do you got to do? Dot product of two arrays. Okay, and we have to do x dot x dot t. So this will give us the dot product of the two arrays. So broadcaster, what's broadcasting in NumPy? So let's see actually how it goes. So let me first write it. So the elements-wise broadcasting, you just do x times broadcaster, right? So what we have right now is an x. If you look at x, you see 3, 11, 1, this, right? And then what we want to do is broadcast this array. What I mean by broadcast is that you multiply this column to this column and this column and this column. So you're literally broadcasting step by step by multiplying column by column. So that's the broadcasting in NumPy. Okay, the next thing, diagonal. Okay, that one is also easy. np.diag x, as I showed you before in the comment section, I mean in the markdown session. And then you reshape it by reshape. Oh yeah, this was my mistake. What I was doing before was doing this. I was doing like this. So this was my mistake. Sorry for that. You don't have to make a tuple for the input. You just type 6,2 if you want to reshape it. Statistics in NumPy. So with NumPy, because you have a matrix or a vector or list, whatever, you can do statistical thing. Sum, max, min, and the mean, median, var, variation. Oh, I'm sorry, the variance, and then standard deviation. So np.array, we got this array as an x, and dtype np.int32. This is the way you set your data type. Int32 means that you're using 32-bit system for the np. You don't really have to know that. So to do summation of elements, you just do sum, right? np.sum. So np.sum and x. And to get the minimum of the x, np.min x. What is this? Maximum element. Okay. So np.max x. I know this is quite boring. Average value. So what do you do for average value? np.min x. Median, you do np.median x. Variation, np.var x. And then std, right? So now let's start combining stuff together. We have a bit more realistical array, X. This is quite big. So if you want to see the shape of the matrix, you just do x.shape. Oop. Okay. And then extract the first column of X. How do you extract the first column of X? Okay, admit. Welcome. So how do you extract the first column of X? Can anyone of you guys unmute yourself? If you're still listening.
Feel free to use the chat as well if you want to.
Yep. Oh, sorry, I cannot see the chat, so if someone comment in the chat, comment or Nick, you guys
Yeah,
can.
I'll let you know.
Yeah.
Do you just index into it? So like with square brackets?
Square brackets. So what we are trying to do is to get the first column, which is 1, 12, 126, 63, 48, blah, 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 to 34.
You do, yeah, sorry.
Mhm.
You do x square bracket,
Mhm.
colon, comma,
Yeah.
0, square
Yeah,
bracket.
that's correct. So what this means is that, so before the colon, you want to get every row. So before colon, it represents row. After colon, after comma, it represents column. So row, comma, colon. So for the row, this column means you want to get everything, every row. But for the column, you want to get the zeroth index of the column. So this will give you everything in the row, but the first thing in the column, which is 1 to 34. All right. And then the last row. What is the last row? This one. So based on what we've learned just right before, what is it? X. You can say, but
Minus 1?
Yeah, this can be the fanciest way. Just if you just do -1, because -1 is indexing the last one. So from the beginning, you start from 0 and you end with you don't know, right? So this is why -1 is existing in Python. So since you don't know the last index of the list, you can use length, but you can just access the last element by just doing -1. So this whole thing is the element of this big array, right? So you can just do -1. Calculate the mean of the elements in the last row. So last row was this thing. So to calculate np.mean, what is it? X -1. The diagonal of the X. So np.diag X, you get 1, 2, 3, 2, 2, 3, blah, blah, blah. Yep. And then variation, np.variation. And then np.diag X. Quite easy, right? Straightforward. One more NumPy problem. This was optional. There's no answer to this because for this one, I just wanted you to create any kind of matrix. But I provided the prime list. I just wanted to do some, I don't know, some fancy thing. So x prime 0 for x in range 1 to 6. And then I copy this into each row, and then I'll change to 3 and 4. So this matrix will go over 1 to 6, and x times prime 2, prime 3, prime 5. It just, I don't know why I did this one, but it just, there's no answer to this. So if you have just made any matrix, it's okay. So let's make it as a NumPy array. Let's do np.array and then matrix. Matrix diagonal, np.diag. We're just exercising, practicing, right? And sum and min of the diagonal components, which is np.sum of the matrix diagonal, and then np.main matrix diagonal. Right. This is just a print function. Yeah, so this was the end of the NumPy notebook. Do you guys have any questions? Or was it too easy? When you go through the notebook, the key thing is to read carefully the markdown session, because that explains everything. Any questions?
No, I just wanted to say I thought it was quite all right. Like, if you've never seen NumPy before, it was all right from difficulty and stuff.
Right.
I've got a question for everybody. How many of you have completed the notebook, honestly, before you've come to this session? So maybe if I could get like a yes, no in the chat or something, or you give a thumbs up. Jeffrey has, Jake has. Anybody else?
Michael has completed them, and Tim has done the first 2 parts as well.
Nice. So I'm assuming everybody else is a no. Would that be right of me to assume? From somebody who hasn't responded yes?
Because have you guys seen the first introduction video? Because there I explained that this whole tutorial class is a flip tutorial, which is you learn it first, and then I'll show the answer. Okay, due to the time constraint, let's go to the Pandas. Oh, and by the way, I'll upload a solution right after this lecture, okay? So don't worry about the solution. And then the Pandas. Okay, import. So the first thing we're gonna look at is series and data frame. So what is series and what is data frame? So let's first start by making a series and making a data frame. So if you say pd.series, pd is pandas shortened, pd.series 1, 2, 3, and like any list, you'll see something like this. You get the index and the value here, right? So this is a series, just literally a series. Okay, now let's make a series in a different way. This is one way to make a series, but let's make it in a different way. So I'll say module score dictionary. You can make a series by assigning a dictionary into it. I'll say database value is 90, securities value is 70, and math, machine learning 80, 70 and 80 respectively. And then I say, because this is a dictionary, you can say pd.series, and you put dictionary into the series library. So PD has attribute series, and if you put dictionary into it, you're making a series object. And by just changing it to data frame, like module score and columns score, you're making a data frame. So PD.data frame, you're making a data frame. So if you see that, this is a series. So type is pandas.core series, the series. This is a data frame. What's the difference? It looks exactly the same to me. What is the difference? The difference is that in the series, this is it. In the database, in the data frame, you can have multiple additional columns. So you can add it in the column-wise way. So if I say score, this, I can add, I don't know, apple, banana, or orange column into this data frame. So the series can be called a data frame that has just one column value, that has just one column, right? So let's go into the example. I'm making.
Can I ask a question?
Yep.
Do they still have the same methods and attributes, or do like the series in the data frame, or are they just exactly the same and just different that you can add more columns in the data frame?
That's a great question. So actually, if you look at this data frame, let's say I have score column, an apple column, and banana column. If you call data frame, and then if you access square bracket score, is exactly the same as series. If you access data frame square bracket apple, is exactly the same as series. So data frame has all the attributes that series have, right? But data frame has additional attributes that series doesn't have. Is that clear?
Yeah, I got it. Cool, thanks. Yeah. And one question: how do you, in the section you will actually show, like when you make pd.dataframe, this is like a nice table, and above is just like the data. Did you do something different there? Do you know what I mean?
Yeah, I know what you mean. Like this. In the below, you saw like a table, but like here, yeah, it's just because how Jupyter Notebook works. Okay. If I didn't specify anything, it just created a beautiful table. But since I just printed it, it just print this.
Oh, okay. So
if you use Python in the terminal, you'll see this.
Yeah, sure.
And you only see the beautiful thing in Jupyter Notebook.
Yeah. Yep. Okay. Great.
Okay, let's go into the example.
Sorry, I have another question on that one before we continue. So, why is the series one? Why is the database 90 like tabbed in, kind of one space indented?
Oh, this one.
Yeah.
I'm not quite sure, but I don't know. I don't think it matters that much.
No.
I think Python has like a magic method, like __ string. When you print something, you just set how it is printed. Maybe in the series library they set something, I don't know, I don't know. Doesn't matter that much. Okay. Solar data. Actually, this Zoom call was just a 1 hour call. I mean, the session was just 1 hour session. and we have 20 minutes length of pre-recorded lecture, which is very, very important. So yeah, because this is our first time doing things. The timing issue, we have the timing issue.
So what we could do here is just release the lecture after the session. If you think that the remaining 20 minutes we can go over this notebook in the next one, we can just upload the pre-recorded session online such that people can view it whenever they want.
Yeah, sure, no problem. Yeah. Yeah, I think that's a better solution, better one. Okay, so in the solar data, we have, as a column, we have name, satellite, and AU, diameter, and then we have values in each column. Solar system, if you print it, you see this table, right? If you say solar system.d types, you'll check the data type of each column, right? Object int float. So these are quite frequently used attributes, functions in the Pandas. Head, tail, which is great for checking the head and tail of this data frame. Index, columns for retrieving index and columns in early. And then, yeah, the other things. We'll look into it. Let's say, just for the sake of simplicity, solar system is df. If you say df.head, you'll get the head rows of this whole data frame. So it is set to 5 initially. If you say head 2, you'll get 2 heads. If you say tail 5, you'll get 5 tails and 1 tail, right? If you say df.index, index, what was it? 1 to 8, right? So here, 1 to 8, df.index. Admit. df.index 0 of yeah, obviously the first one here. df.columns, you just get the columns of the data frame. And then this is quite important one, df.lock and df.ilock. So this I means that you're accessing the data frame by index. So if you say df.log1, this one is df.index. So the computer will find 1 in index, which is Mercury, right? So it outputs Mercury. df.ilog0, you don't have 0 index here, right? But if you say ilog, it is indexing like on Python list, like you start from the 0, right? So that's why if you say 0, you'll get the Mercury. Okay. df.lock0. You see, it gives an error because there's no 0 index right here. It just have 1 to 8. Okay, and then df.values. If you say values, it gives a Numpy array, which is very great function, which is because when you have data, you sometimes have the data in the Pandas frame, and you want to use that in machine learning system. To do that, you have to change it to Numpy array, right? This does that. df.values, change it to Numpy array. df.describe, it'll just print out all the statistical information, quartile, max, min, standard deviation, everything you can check. Sort values by diameter, ascending false. So what does this do? So this do sort, sort values by diameter from the biggest one to the smallest one. You see index has changed, right? This is just a sorting. Okay, to do resort the data frame by number of satellites in descending order. Anyone want to volunteer? By satellite, right? And then ascending.
Equals false.
Yes. Okay. Before 2006, Pluto was classified as a planet, blah, blah, blah. So we're gonna add Pluto back. So what we do here is you have to log 9. We didn't have 9 before. We're adding it by doing 9. So now we have this data frame, Pluto 0, 39, 2.3. And then reclassify Pluto as dwarf planet again. So we're gonna remove this last row again. What do you have to do? You have drop attribute. df.drop. You can choose index, which is 9. Dropped. Okay, let's read the data. This is really, yeah.
For these two, for adding and removing something to the end, what if you didn't know the length? I guess you could just do length of that.
Oh,
And
right. Normally, just to be honest, I would just Google it. It will give you a prompt answer. Let's see. Any of you have any ideas? I'm gonna try it. No, obviously not.
I think we can check the index first, and we can see what's the maximum index.
Yeah, that's right. Yeah, of course. So what is the, if you say no, this is not, this will give you the 9, right? So this will give you the length, which is the number of rows. So you can just say index equal to maybe length of df. Yep. Was that a good answer? I mean, there must be way much better answer than this answer, but for now, I'll just keep with this one.
yep, that works. Thanks.
Yeah. So read data with Pandas. You got read CSV, read JSON, read SQL query. I mean, this one, if you're not doing something crazy with SQL, maybe if you're in a corporate, you'll use it very frequently, but you're gonna do CSV or JSON if you're just doing individual projects, something like that. So in the CSV file, which is a comma separated values, you have first row is usually a column. I mean, yeah, the column. And you have all the values after the following rows of the CSV. So if you go to the data section, we have IMDb movie data. It looks like this. The CSV looks like this. The first one, rank, title, genre, description, blah, blah, blah. And from here, this is the rank. This is the rank. You get the idea, right? And then this is the title, and this is the genre. All right. So we'll read this CSV, and this will create really large 10,000 rows of data frame. Okay, and by just setting index call to title, you can set the index name as a title. Okay. Try other two options. Movie.iloc. Anybody tell me the answer of these output? Movie.iloc2. This is the movie data frame. What happens if you do iloc2? This is the second.
The second.
Yeah.
The Prometheus shouldn't be just given out.
Prometheus. Let's see. Nope. It was, what was it? Was it Prometheus? It was split. This one. Because this is iloc, always. I is like a index, right? 0, 1, and 2. You get split. Right? And sort the table by ratings. You remember the sorting function? What was it? Sort values, right? Sort values. So movie.sort values by what? Revenue millions. By revenue millions. And then ascending to true. Oh. True, because it is descending order. Yeah. Let's just print out the first three one by just doing this. So this was sorted. If you see revenue, you see the 0, right? It's descending order. So a kind of murder. Ooh, this got 0 revenue. Okay, sort table by revenue in ascending order. Let's just skip this. You can just say ascending to true, right? Movie, the general value counts head. The value counts, this one, is used to get a series containing counts of unique values. So it's printing out unique values. You have 50 drama, adventure, sci-fi, 48 drama, and 31 drama and romance. Okay. Yep. Okay, this one is quite important as well, the masking operation. So let's first run this. Movie, in the movie, right? From the outer one, you get the movie, right? Square bracket. In the movie data frame, you want to filter out movie runtime minutes. So runtime minutes, where is it? Yeah. You want to access this column. You want to get the data frame filtered out with runtime minutes greater or equal to 170, right? Let's see. 170. You only have movie that has runtime with greater than 170, right? And by just doing sort by values and rating, you'll get a good rating movie which has 170 or more runtime. And then by using the masking operation, extract the movie whose meta score is bigger than 95 and sort the results. Okay, this is also very similar. So let's actually copy the above one. So what we have to do is just, we want to access the meta score, right? But greater or equal to 95. And you want to sort values by, what did I say? Year, right? And then ascending to false. You do this, you're getting this filtered data frame. Are you on the same page?
Yes.
Okay, great. The last one. Extract movies who are directed by one of UCL's alumni. Tenet, Inception. Who is that? Who is that director?
Christopher Nolan.
Obviously, yes. So we're gonna extract Christopher Nolan's movie. So director to Christopher Nolan. Wow, Interstellar, Dark Knight, Prestige, Inception, Dark Knight Rise. Straightforward, right? This is the masking operation, like filtering out by giving the condition inside a square bracket of movie data frame, right? Okay. So these below thing are the Pandas exercise because we are suffering from timings. I guess I'll leave it here, and don't worry, I'll release a solution to the GitHub. And the next one, which is Matplotlib. Nick?
Yes, thank you.
Can you take over? I'll stop sharing my screen. Yeah, before stop sharing my screen, do you have any other questions?
No.
Okay. Nick, could you take over?
Yeah, of course. I will share my screen here. Okay, so can you guys see my screen?
Yes.
Okay, great. Okay, so for this session, I will introduce you some solution about the Matplotlib here, and I just hear someone say it's a little bit hard, and I will try to cover all of this because it's not very long. So I will try to start here. So in conclusion, Matplotlib is a Python data visualizing library. If you are in the data explore, if you want to explore your data, you may want to visualize in most cases. So the Matplotlib is very useful to visualize all the data that you want, and you can analyze and clean it accordingly. So for the people who did not install the Matplotlib library, you can just use this command line to install it. But I believe all of you have done it. So let's import the Numpy pandas just introduced by Danny before, and also the new libraries that we are introduced here. So we give the short form PLT to stand such long name. And the first one is very, very easy. We want to, if we want to plot a y equals to sine x here, we can just simply give two sets of values. So because, you know, in computer, we cannot present or store the continuous infinity numbers. So we take an alternative. We give a set of points here. So they are from 0 to 3 pi, and with 0.5 as interval. So we get a series of points. And y is also the sine value of the points of the given x. So let's see for the x and y here. So you can see the asset. That means we will check if length x equals to length y. If not, the program will shut down. So if you just have x and y, you can check here. You cannot say is that a sign. You may have hesitation, right? You cannot know what's a y look like. So in this case, we would visualize it, and by using this kind of by using plot function in the library. So the first parameter here is just your x coordinate, and y is y coordinates. So just like the data here. So we are going to plot it. Oh, sorry. So here you yeah, that's right. Yeah. So please remember, please code the plot dot shown here. Otherwise, you may not have any problem, but I recommend you to do so by code this. If you forget, it doesn't matter. And you can also assign title here, and also y label and x label. If you type the grid here, you can have the grid lines just like shown here. If you delete this, you can see there will be just a simpler graph. So you can determine if you want it. So here, we want to, how about if we want to draw a lot of lines within one graph? For example, we're drawing y equals to x, and the x squared and x cubed here. We just simply type the formula here. So the 2 stars means the square. And if you type, that means if you type 2 is square and type 3 is cube, right? So, and that's very similar. So I think we can just copy this y values into the none here. So it's easy. And we also assign the x label and y label, give grid. And this time we will have a legend, which indicates, sorry. Here we also don't forget to plot the show here. So the legend will show each line like this. So we have a label here. You can check which line is which. If you try maybe 100 lines, no, 10 lines and or more, so you can check this to which color indicates which lines here. So that's also easy case. So now this is only line graph. So we're going to try some more advanced graph here. For example, scatter. So for scatter, we also use data presented by Danny, that is a move data. We also use, let's review here. If we want to read a CSV file, we should use this function, right? And we present its columns. So we know what attributes here, just like you've seen before. So if we want to draw a scatter plot, we can simply use this, type like this, and you assign the x and y. So the x will be the dependent variable should be revenue, independent you should be the rental. So we draw this. Okay, so this is simple. And here you can see we will read a new data set that is named as the scatter shaft data. So we'll also use the same read CSV. And we assign the index column in the first columns. Be careful here, we use a map function here. So what map works is that in the original data set, the scatter class is not int, it's just a float number. So, but in fact, for class, it should be int because we don't have 1.5 class such things like this. So we use a map each float numbers here in the scatter in the class column of scaters into an int. So that's how map works. But if you don't put the list outside here, you will say this is a map object that is not easy to virtualize. So we convert it again back to the list. So that's not important, just to introduce you. And we plot we print the first 20 rows here. You can see there are some coordinates and the class for each points here, data points here. For this part, it's a little bit hard to understand, but I recommend you to skip it because this is to assign a set of variable numbers, class 0, class 1, class 2. They are all the data frame. They are all data frame. So what we are doing here is just split the data set according to a class index. We want to get a data frame only contains class 2, and one data frame only contains class 1, and others contains only class 0. This is just used for the further plotting purpose, so that's not matter. Okay, so if we want to calculate, just for recall, using the Numpy library to calculate the centroids of all the points here. But now we have the class 0, 1, 2. So we are going to calculate the central points for each class. We can simply use the Numpy min, right? This is class 0. Similar for the class 0, the x coordinates of the centroid should be this, and for class 1 and 2, it's similar. Just replace the variable number. And for y, is there any question in the chat? I cannot say, but if you have a question, you can just say.
No questions so far. No.
Okay. Okay. So for the y, we calculate the y columns, right? We use the class 0 is a data frame, and we use the y columns number to calculate the mean, right? Okay, so we got the centroids coordinates in this two list. Okay, so next we are going to plot all the data. We are going to use different marker and colors to represent different classes, and also use the cross to represent the centroids of each class with the same color to that class. So I think so here we're going to use the scatter plotting, right? Just so we introduced before. Here we are going to plot the scatter points graph here. So yeah, so have a see here, this class dict, just like I put here. This is a dictionary data type. It has a key and it has a value. So the value can be any other type of the data in Python. For example, this is a data frame. Of course, you can also assign a int number, a list, and anything that you want. So here we just use 0 as a key to present, to store the data frame class 0 into that dict. So here, just you can see here, so we have a loop here for class. The class is 0, 1, 2, right? So the I should be convert to the string data type, because here you can see that in the dict, the key is a type of string. So we have to convert it to same type. If you don't have this, then the I should be, for example, 0 is a number, it's an int, not a string. So you cannot be consistent to this. So, and here we are scatter this the first parameter should be the x coordinates, right? So the okay, sorry. So you can say this part is a class 0. Is a class 0 is a data frame whose class are all 0. So we are here to assign the coordinates x here, column x to as the x coordinates. Similarly, this should be sorry. So this should be y, right? So we can run to see what happened. Oh, sorry. Oh, this should be scatter as well. So here, can you see? So the first line here, here just to draw the data points that we have here with different marker and different colors here. And this is drawing the cross. It's a centroid that we calculated here with the cross, but the same color as the class, as the points within the class. So that's the scatter. So sometimes we also want to draw a picture of bar plot, right? So if for bar plot we use plot plt.bar and to draw a bar plot. So xticks is to use to assign the x coordinates labels here. So here we also present we also generate a data set by ourselves. This is from this website. So we are going to see how popular for the programming language in 2080, I think. Yeah. So this is the number that we have had, and now we are going to assign the x positions. That means on the x-axis, what's the label's position that you will be. So we assign this. And here we are going to draw the bar chart, right? So if we want to draw the bar chart, it's similar. We get the x position just like here. That is x-axis, x coordinates. You can understand it like this, and the y should be the percentage. And for xticks, because you can see x positions is a set of number, right? From 0 to 6. But we want the x label to become the language because we see they are a pair, jazz corresponding to 69.8. We want to replace the numbers without any meaning to the language labels that we assign here. So we can set the first to x position, and the second parameter as language. Right? That means we replace all the x positions to the labels here. So let's see. Oh, x positions, sorry. Person. Oh, sorry, typo. So here we got the graph. And you can use the x label, y label, title as before to assign the access name and the title of the graph. Okay, so how about if we want to adjust the bar width for each bar here? We can simply, for example, here we set to 0.5. You can assign by yourself anyone that you want to try, but for example, we just choose 0.5 here. So similarly, we use positions, and for the y coordinates, we present percentage, and we can add one more parameter called width equals to bar width that we assign here. So the ticks is the same, I think. We can just copy. Okay. Okay. So where is it? Okay, the scatter, right? Oh, what's wrong with it? No skate. We are going to draw a bar chart, not skate. So you can see we adjusted the bar width, right? So there is a question. I'm not sure if you have tried. If what will happen if we adjust the bar width bigger than 1? For example, if we adjust the 2, you can see. So that the overlapping may happen because you can say the 2 and 1 is a percentage, right? If I assign to back to 0.5, the whole weight is 1. If you assign 2, that 1 bar will occupy two units space here. So the higher one will occupy the second space. So you will not see the HTML's value here. So avoid to use a bar with more than 1. Okay, so later on we are going to, if we want to use, sometimes we want to compare 2 groups or more groups of data within one graph, right? So the next step we are going to do is to compare the same data for 2080 and 2020. So we want to compare the trends between for the language, for the programming language, and we want to compare the data between them. So we have a new group of data for 2020 here. That's also corresponding to each of them. You can check online this data for you. And this time, because we want to drive 2 groups of data within one graph, we need to use the subplots. It's also kind of function within the POT. And we also assign the bandwidth to 0.4 because the total weight is 1, and we are going to draw 2 bars. So if we assign to 0.5, that will occupy the whole space, and there will not any padding. So we assign 0.4. That's similar here. Firstly we are going to draw the percentage of the first group of data. They have the same sorry, they have the same x coordinates. But you have separated 2 bars, right? So you have to add a bar width. So that means you move one from another, otherwise you will overlap. So you just add a bar width for second group, and the y should be the percentage 2020. Right? In this way, you can draw you can draw two bars within one at before. However, you should also assign the ticks here, and that is a little bit tricky. In fact, that is if we want to have the label in the center of the 2 bars, we need to consider if let's just at first we use the same we use the expositions to draw the labels. Let's see what will happen. See, the labels is in the first bar center, not in the 2. So we want to adjust it to the 2 bar center. In fact, if you check, you can see we need to add half of bar width. So here we adjust it to plus 0.5 times bar width. What's the name? Bar width, right? So that will be a center. So that's a little tricky. You need to adjust it, maybe, but don't worry about it. If you are doing visualization, you always ignore these kind of things. But after you draw a picture, you can adjust it by yourself. Okay, then sometimes if we have so many languages here, just assume if we want to draw that we'll have very wide graph, and that may not have a good layout. Sometimes we want to convert it into vertical from the horizontal type. So we are going to use bar edge. That's very similar. I think that because of timing issue, I don't want to type all the num here, but I will try to show the solutions later and post on the GitHub, and you can check it. One thing that you have to bear in mind is that if you change from the vertical to the horizontal to vertical, you have to change the X labels and Y labels here. So you will see, you can just think about it and try to check the code later. So all the X and Y labels should be exchanged. Okay, so the final things is to we want to integrate many plots within one big one. So we also use a subplot here. But this time we won't draw two bars, for example, two bars in one graph. We are going to draw 4 separate graph, but they will present in one frame. What does it mean? For example, we assign a 2 times 2 grid here. That means we have a big picture and we separate into a 2 times 2 array, and each cell here will draw a subplot. Okay. So for the first, we are going to draw for the first cell. We're going to we're going to draw a scatter graph, and that's just a random X and random Y, random. So only difference between the previous one to here is that the axis we should for the axis right here we should assign the cells. I should not sweep that. So for this big frame, this one would be 0, 0. So here we are going to draw the scatter at here. So this one should be 0, 0. And scatter just the X and Y we generate randomly here. And for the second, we are going to draw a bar chart at here. So that should be 0, row 0 and column 1. So the axis should be 0 and 1, right? This is a bar chart, and the X coordinate is just a 0 from 9. Be careful, this is not 10. It's just a 0 to 9, and the Y should be X squared. So similarly, we are going to get a multiple bar chart here. So the only thing that we should do is we want to draw here. So it's X 1, so that is row 1 and column 0. So the multi-bar graph will be drawn here. So for the last one, we're going to draw a histogram graph. So to here. So it's just 1 and 1. Okay. So let's see. Sorry. Oh, there should be.
You have a none at the end, the last line.
Where is the none? No.
Just at the last line of the cell, there's a none. Yeah, there you go.
Oh, okay. So we just use plot show. Oh, no, there is anything wrong. Take 1 or 3 position. Plots, sorry. So let's go. So here you can see we just plot a big picture contains 4 subplots, right? In fact, these functions or this graph that we use here is only a small part of Matplotlib. There are many more. So if you have time, you can explore more through these resources. But in fact, in when you do a machine learning, when you try to understand the data, you are not to remember all the functions that we use here. You can just try to know what is the type of graph that Matplotlib can do. Then when you want to use it, you can search and you can just make a notes here, and you can just copy that when you need it. So you don't have to remember all the parameters and all the functions here. So that's really difficult. So you can just simply check the library's instructions instead. So that's on my part. Comment, Danny. Thank you.
Thank you, Nick. We've run fairly over time, so I think we're gonna skip the fourth notebook.
Right.
There's gonna be a pre-recorded video being uploaded to the YouTube channel with some content on like the mathematical basics that are gonna be required for the introduction to some of the basic machine learning algorithms. Yeah, so I think we can stop the recording now. And if there are any questions by people on like particulars, we can take them offline.